Are we going?
We're going.
We're going. Okay, we're on. Okay. So Friday we did negative exponents through division, right? Nothing stuck. So here's my attempt number 2 at trying to get you to see what negative exponents mean, okay? So today I'm going to teach it with a pattern. I need you to notice the base number's the same all the way here, right? Notice the pattern that I'm making with the exponents. 4, 3, 2, 1, 0. Negative 1, negative 2, negative 3, negative 4. So there's a pattern here, okay? All right, so 4 to the 4th power. So 4 times 4, 16. And then the other 4 times 4 is 16. What's 16 times 16? 256. Okay, 256. Fill it out as we go. Stay with me. 4 times 4 times 4 times another 4.
16.
And then times another 4. It would be 256, I think.
Wait, don't you do
4 times 4
16.
times a 4, 64.
It's not 28.
64. Times another 4. It's 256. Get a calculator and try it. Somebody check me. Oh my gosh, we're actually going to do that. We're going to get a calculator and try this. Okay. All right, hurry up. My time on YouTube is going. Hurry. Just do 16 times 16.
Miss, you can't see the papers. Very big.
It is. You can't see nothing?
256.
Oh my. Just press pause.
It's okay. It's all right.
There it went.
There it went.
Yeah. Pause.
Okay, it's so good now. Okay.
Nope.
No, it's just because your head, like, it
Oh.
makes it not.
So if I just stay out of it?
No, you can't.
Oh, I can't have my hand on there either? It doesn't like anything, basically.
Yeah.
Okay.
64.
60, well, times another 4. There's 4 4s.
Oh.
This is not going well, Miss Bemis.
256.
Okay, 256. We all agree now that this is 256? Okay, Joseph only said that 5 minutes ago. All right. Okay, 4 to the 3rd power. 4 times 4 times 4 is 64.
I told you.
Okay. Okay, then we have 4 squared, which is 16. Okay, I'm going to stop right here, and I want you to notice a pattern. To go from 256 to 64, we divided by what? 4. To go from 64 to 16, we divided by what? 4. Okay. So to go from 16, we're dividing by 4 again. What? Right? What's 16 divided by 4? 4. So 4 to the 1st power is 4, right? We continue this same pattern of dividing by 4. 4 divided by 4 is?
0.
No. 1. And on Friday we looked at the fact that anything to the power of 0 is 1, right? And here it is again. Anything to the power of 0 is 1. Okay, now we get to the negative exponents. When we go down here we go. We divide by 4. 1 divided by 4 is 0.25, which I don't want to go decimal form. I want to say fraction. 1/4. The negative exponent doesn't make it be a negative number. It makes it be a fraction. Okay, so then I divide by 4 again. So if you picture a pie that's cut into fourths, and now we're cutting each of those fourths into 4, and so we're at 1/16. So I like to look at it this way. 4 to the 1st power was 4. 4 to the negative 1st power was 1/4, right? 4 to the 2nd power was 16. 4 to the negative 2nd power was 1/16. 4 to the 3rd power was 64. So 4 to the negative 3rd power is 1/64. Don't say negative 64, okay? 4 to the 4th power was 256. So 4 to the negative fourth power is 1 over 256, right? It's all starting to click. Well, it kind of clicked on Friday and then it left you again. So I gotta say something to make it stick in there.
It'll be gone
Okay,
before-
it'll be gone here.
It'll be gone by
Okay, it'll be gone by third hour. Okay. All right, here we go. 3 to, yeah, we'll reteach it on Wednesday. Okay. 3 to the fourth power.
Oh, well, I know.
There's 64.
81. 81. 3 to the third power. 27. 3 to the second power. 9. Okay, this time, in this pattern, I've changed the base number, but I kept the same pattern with the exponents, right? What are we doing to go from 81 to 27 this time?
Dividing by 4.
Dividing by
3.
3 this time. To go from 27 to 9, we divide by 3, right? So 3 to the first power is 3. I'm dividing by 3 each time. Divide by 3, and there it is again. 3 to the 0 power is 1. Anything to the 0 power is 1. Okay, we go again. Divide by 3.
1 over 3.
1 over 3. What's the next one?
1 over 9.
1 over 9, then
1 over 24.
1 over 27, and then
1 over 81.
1 over 81. So in your journal, 3 to the negative third is not negative 27. What is it? 1 over 27, right? Right here, you just did it. 3 to the negative third is not negative 27. It's 1 over 27. It
So then how did I?
makes it be a, well, you just didn't do 3 times 3 times 3. Okay. Okay, here we go. Which when your base number is a variable like we looked at on Friday, then you would leave it like you had it.
10 times 10.
If you know the base number, you could go ahead and multiply it.
1,000.
All right, here we go. 10 to the fourth power, 10,000.
Yeah. Oh.
10 to the third power, 1,000. 10 to the second power. Okay, what is the pattern this time? Divide by 10. And so we're dividing by 10, right? Divide by 10. 10 divided by 10 is 1. This is a weird one, yeah? Wait, I got off one.
10, man.
Oh, this is 100.
10.
I got off one. 10, yes. I lost a 0. I lost 2 zeros on that step.
That's all you have to do is put the number 0 to the exponent.
Yeah, when it's 10, yeah. Okay, so what is 10 to the negative first going to be?
10 over 1 over 10.
1 over 10. So 10 to the negative second,
1 over 100.
1 over 100. 10 to the negative
1
third,
over 1,000.
1 over 1,000. There I am forgetting a 0 again. And 1 over 10,000. Okay. All right, so let's look at some of these down here at the bottom. So 3 to the third power is
27.
27. So 3 to the negative third power is going to be
1 over 27.
1 over 27. Okay, now here's a new part. Here it's going to get a little tricky. Get ready.
I'm gonna go home.
1 over 3 to the third power. Well, what is 3 to the third power?
27.
So this one is also 1 over 27, right?
No,
These two are equivalent to each other, right?
1 over negative 27.
Okay, now here we go. This bottom one. Here we go. Okay. Right, that we're going to do a little bit of work here so I can make you make sense of this. You just told me that 3 to the negative third is 1 over 27, right? So here's what we have, and I want you to write this down. We have 1 over 27. That's what we have right now, right? This bar right here means divide, right? So we have 1 divided by 1/27.
It's just 127.
And so when we divide fractions, we do keep, change, flip. So I've got 1 times 27 over 1, right? And so it's just going to be 27.
That is very. That's like a plus plus.
It kind of is. It seems like a plus plus problem, yeah. So my brain, here's what my brain thinks. Cold record, knock it off. Here's what my brain thinks. When Anytime I see a negative exponent, I think, oh, I just need to flip it. So like right here, I saw a negative exponent, and what happened? I just flipped it, right? So my brain, like I guess I just jump to the shortcut all the time where a negative exponent causes it to flip. Okay, let's look at another one here. Here we go. What is 5 to the first power? 5. What is 5 to the negative first power? 1 over 5. Very good. What is 1 over 5 to the first power going to be? 1 over 5. Again, there's no weird negative exponents. No weird flipping needs to happen, right? Now we have 1 over 5 to the negative first. So what do you think it's going to be? It's going to be 5. Yes. Now, I can go through the whole step of, okay, this means 1 divided by 1/5. That's what that means. Keep, change, flip, and I get 5, right? So when you see a negative exponent, it just makes it flip. Flip. If it's in the denominator and it's a negative exponent, it goes to the numerator. If it's in the numerator and it's a negative exponent, it makes it go to the denominator. Yeah. Okay? All right. Yeah. We're going to try it today. Okay. I need everybody to go get a notebook paper. We're doing a travel math today, yes. Yeah, you're going to get done. Hurry up.